I hope my screen is visible.
Yes, we can see your screen wave.
Okay. So firstly, let's start with the architecture diagram. So what this app really is about is that there's a simple front end. I'm going to be showing the front end in a few minutes, and the front end will display a list of few buttons on the screen, and the users can click a few buttons, and upon registering a click in the back end, there is an application load balancer sitting in front of it, and behind the application load balancer lies a set of EC2 ECS Fargate containers that host the backend, and these two enable the logging of the clicks to DynamoDB. So let me open up the website. Just a second. Yeah, so this is the front end that I've built. This is a simple front end with just a few buttons, and when anyone clicks any button over here, uh, let me open up the architecture diagram. So when a button is clicked, the click each click will capture a set of attributes. The attributes are the name of the button that was clicked, the location of the user. The location will include the city and the country, the URL of the button that was clicked, and the browser of the user. So if I have to test it, I'll just click on Google, and it should ask me for the location permission. So we can see that it is asking for the location. So if we click on allow, then yeah, we can see that the click is locked successfully for Google. And where are these clicks going is that these clicks, after hitting the backend and the backend container, the clicks will capture a bunch of information, and all that information will be stored in DynamoDB, which is a managed NoSQL database on AWS. So if we open our DynamoDB, just a second. Yeah. So this is the name of the table that I've created, and we have to click on refresh. So yeah, so these are the attributes that are captured by the click in the backend. So the first one will be the browser, that is the name of the browser of the user. The second one will be the name of the button. So we saw a bunch of buttons with names, so we clicked on Google. So we'll look to find Google over here. Yeah. So yeah, I think we found it. So this is the button that we've clicked. If we look at the timestamp, we can see that it should be from here. Just a second, it's on the next page, I think. Uh, yeah. So this is the timestamp that we were looking for, 1:07 p.m. And the name of the button was Google. So this will capture a bunch of information such as the URL, which should be Google, and the device type, it was a desktop. If we can remember, it was a desktop that we clicked it. The platform was Windows. I'm using a Windows machine, so the platform of the user's device will also be captured. The city and country is currently displaying unknown because I'm using a subscription based API for the capturing of the locations, and so there's a limit to that, and I think I've exceeded the limit. So so this is actually a fallback. If the location is allowed and the location can't be captured, these are the fallback values that are unknown. So yeah, these are the attributes that will be captured with all these information. So the next step will be to store this data somewhere, and we are storing that inside DynamoDB. So what we can do now is, in order to analyze this this bunch of raw data, we can use a combination of many AWS services. So the first one will be to send this data to S3. If we try to directly send this data, like if we directly try to export this data, it will not make much sense because it will be very hard to analyze the data since it is not structured properly. So what we can do is, we can write a Lambda function. Let me just open the Lambda console. So this is the function that I had written for it. Yeah, we can see the code here. What it's trying to do is, firstly, I'm initializing the resource as DynamoDB, which indicates that this Lambda function should connect to my DynamoDB. And then what we have to do is, I want to automate the process of sending each day's records to S3. So what I've done is, I'm writing the Lambda function so that the Lambda function will scan all the items inside the DynamoDB, and then it will try to convert it into a standard format. So we can see it here that the format will be Parquet. So I had multiple options to transform and store the data to S3. The most common examples would be either CSV or JSON. But since we're trying to analyze and visualize this data analysis would be simpler if CSV. But what I wanted to do was, I wanted to visualize the data. Like examples for visualizing the data would be what days registered most number of clicks for a specific button, or from which location are the most clicks coming from, etc. So yeah, so for this I was using Parquet. So a little bit about Parquet is that it is a column major storage format, while CSV and JSON are row major. Like they store data in the form of rows. They organize data in the form of rows, while Parquet will organize the data in columns, which will make it simpler to extract and analyze the data. Does anyone have any questions?
Rohit,
Yeah.
hello, can you hear me?
Hello. Yeah. Yeah.
Yeah, just will you just explain what is a row major and column major so that it will be easier for us to understand Parquet buffer.
Okay, so Parquet is nothing but a file format. We've all used file formats like for example, .txt, .html, etc. The same way, Parquet is also a file format.
Mm.
What it does is, Parquet will try to store the data, will organize the data in a columnar approach.
Okay, okay. Like
Yeah.
similar to JSON, I think so.
Yeah, it is similar to JSON, but it is similar in an opposite way. JSON will try to store the data in a row major format.
Okay,
So the approach followed in JSON and CSV is a row oriented approach, while in Parquet it is a column oriented approach.
okay, okay. Means
So yeah, Parquet is specifically designed for data storage and retrieval.
Okay, okay. Means it's for each row we create a column value for that each row.
Just a second, I'll show you with the DynamoDB. It will be
Okay, okay,
simpler.
yeah, yeah.
Yeah. So what we're looking at here is a bunch of data, right? So the each column will have a title. I think you can see it, right?
Yes, I can see.
Yeah. So if we try to use JSON or CSV, it will store it in the format of like it will store each row in a row major format. Like each row will be stored first, followed by the next row, followed by subsequent rows. But if we use Parquet, it will be used in a columnar. It will be stored in a columnar format. So you can easily retrieve all the records in the particular table, a particular column. So if you want to retrieve all values inside the inside the button column, Parquet will be simpler and faster because it is specifically designed for data analytics and data storage and retrieval. So this is one of the main reasons why Parquet is being used in this project. I hope I answered your question.
Yeah, okay, okay. Sure, sure.
Yeah. So coming back to the architecture diagram. Just a second. Yeah. So what we looked at now was the user can click a bunch of buttons and a bunch of information will be extracted from each click of a button. It will flow through the load balancer and the backend and it will get logged inside DynamoDB. And we looked at a Lambda function which will scan the entire table every single day. So one thing that I forgot to cover inside the Lambda function is that, yeah, so this Lambda function is configured to run every single day. So as you can see in the bottom, I'm trying to export data every single day. Okay. So yeah, so this is the file key inside S3 where the data will be stored in the format of year, month, and day. The S3 bucket, which will store the records, will be organized into folders. If I just open the S3 bucket, yeah. So as you can see, this is the first folder, which is the year. I'm organizing the records by year. Inside here, we can see that month. We can see months, February, March, April, and May. So if I go to May, I'll see that 25, and today's date is 25th. So if I open this, I'll see a file named DynamoDB export.parquet. So this is the Parquet file that I've transformed from a bunch of raw data into from DynamoDB into a more convenient file format that I can use to query and analyze the data. So this is the setup for the data after a user is clicking a button. So to automate the process of exporting data every single day to DynamoDB from DynamoDB to S3, I've used Event Bridge. So Event Bridge is a service by AWS where I can specify rules or use cron expressions to trigger Lambda functions. So by using Event Bridge, I can automate the automate the process of exporting every day's records to S3 from DynamoDB. So if I go into schedules, yeah, you can see the schedule. It is named trigger Lambda. So yeah, so this is the cron expression that I'm using to explain this cron expression. It specifies that from every single day, like every single day at exactly 11:59 p.m., no matter the month and no matter the day or the year, and all 7 days a week, this function, the Lambda function that I've written to export the data from DynamoDB to S3 in Parquet format, this function will be triggered every single night, and this will be done automatically. And if we go to the target tab, the target is named the target is export data to S3, which is the name of the Lambda function, So with Event Bridge, I'm automating the process of exporting the data from DynamoDB directly to S3, and this is the final file that we receive from DynamoDB and Lambda. So Lambda will first scan the entire table. It will extract all the data and records from the DynamoDB table. It will convert that data to a Parquet file format, and Event Bridge will pick up this file. It will trigger the Lambda function, and the Lambda function will export the data to S3. I hope I've explained this clearly. Does anyone have any questions?
I think all good, Mohit.
Yeah. So moving on now, what we have in our S3 bucket is the
Just Rohit, one question.
yeah. Go on.
If you 1 minute, yeah. So DynamoDB is from the requester side or it's from the server response side?
No, DynamoDB is in the backend.
Okay, it's backend for every machine you're saying?
Yeah, for every like, so when a user clicks any button, this entire thing is in the backend.
Okay, means each machine follow this setup or set of
Yeah,
process.
exactly. Yeah.
Okay, fine.
Okay. So what we have now is a standard format for the I have a standard file that I can use to analyze, query, and visualize the data. So the first step towards visualizing the data is creating a database. I have a database, but it is actually a NoSQL database. So in order to perform analysis and visualization on the data, we have to do transform the data using the Parquet file. So what I first did was I had to okay. So the first thing that I did was there's a service in AWS called AWS Glue, and it offers a service called AWS Glue Crawler. So a little bit about crawler is that we can specify a source. In this case, it is the S3 bucket, which has the Parquet format, and from the does anyone have any questions?
I think good to go, right? So we can see your crawlers loading resources. Yeah.
Okay. So what I have deleted the crawler that I initially used. So to explain the role of the crawler in this project, what crawler does is I specified the data store as my S3 bucket which contains the Parquet file, and it processes the entire file, and it identifies the rows and columns inside the file. So what I wanted was the schema. basically the schema of the entire S3 bucket records to be extracted right away. So there was an option to do it manually, but AWS glue crawlers can automate it. So if we just try to create a crawler, yeah. So what I have to do is I have to specify the data source. Data source in my case will be the S3 bucket. So if I click on browse S3, this is the table that I want. This is the S3 bucket which contains all the which contains the Parquet files. So if I just click on the S3 bucket and click on choose, yeah. So if I click on we have to specify the glue crawler to crawl all the subfolders. So the S3 bucket has multiple files and folders inside the hierarchy. So if we can see that there's a specific folder for year, specific folders for months, and specific folders for days. So we have to configure it so that it can crawl the entire bucket to detect the schema. Yeah. So if I click on add crawler and click on next. So this is the IAM role. We can create new roles directly from this button, which AWS provides a few basic permissions that this crawler will require, and you can just click on create role. I had a previously created role, so I'm choosing the role, and you can click on next, and then the last step would be the target database and the schedule. So for the database, the first thing I have to do is I have to create a database inside the glue. So if we go to glue, yeah, so this is the database that I've created. This database has one table, and this table has a bunch of columns and rows here. So we can see that there are 12 attributes currently, where the column names are displayed. And about partitions, we saw in the S3 bucket that the partition of the folders were based on year, month, and day, right? So this will be detected by glue as a partition. So if we just if there's a new file of another day, for example 26th May, that is tomorrow, the database will automatically get updated only with a new partition of the day. Since the month and the year hasn't changed, only the day has changed. So glue will detect the change and the partition will be created. So yeah, so these are the partitions that were created. We can see that in the month of March, there were 3 days, that is 2nd, 23rd, and 13th. So these were the partitions that were created for the month of March. Similarly, for February and April. So that is all about the database inside the glue crawler. So the next step would be to choose the database in the crawler. So this is the database that I've shown just now, and this is completely optional, and you can choose on demand, because this glue crawler needs to run exactly only once, because the crawler can automatically detect all the partitions inside the S3 bucket. It can detect the partition of year, month, and day. So all you have to do is create the crawler and run it exactly once. Okay, so since the all that's left is the creation, I'm gonna skip this step because it is already done. The next step would be the Athena. So Athena, to tell you about Athena, Athena is a service that
We cannot hear you, Rohit, for some reasons. Rohit, you there? Cannot hear you.
Rohit, your mic is on, but we cannot hear you.
Sorry?
Yeah, Debajit, I'm saying, Rohit, we can't
Okay,
hear you.
internet issue. Okay, I think some internet issue. All right. Okay.
Hello.
Yeah, we can now. You are audible.
Yeah. So let's get back to Athena.
I think again some internet issue. Just hold on for a few more minutes, guys.
Am I audible?
Yes, now you can. Yes. It's on and off actually, Rohit. Again, same problem.
Um,
Are you there?
yes, sir.
Okay, okay. Yeah, now we can hear you.
Yeah. Yeah. So this is the Athena console. So if we remember, we had created a database inside Glue along with a data crawler. And the database will have all the tables and columns inside it. So in order to query the results from the data source, that is the S3, the first step would be to create a work group. Work groups in Athena, yeah, work group it work groups enables you to kind of isolate your queries from the entire database. So if we choose the data source over here, it will be the from the crawler, the database that we created from Glue, and the database currently has one table, which is the click events. So if we expand the table inside the database, we can see all the attributes over here. So to show the export of the Lambda function to S3, if we just try to test the Lambda function, just a second. Yeah. So what I'm doing now is I'm just trying to test the Lambda function to export the data. So we performed a few click operations a few minutes ago. So to do it again, we'll just perform a few operations. Yeah. So we can see that 2 clicks were logged successfully as of now. So if we go to the Lambda console and try to test this function with a sample JSON payload, I just have to click on test. We can see that the function has started execution. Yeah. So we can see that the function has succeeded in execution, and we can see the message exported 12 records to S3. So if we remember, we made about 12 click operations since the start of this webinar. So we can see that all 12 records from today has been exported to S3. So if we go to the S3 bucket and check, we will see that uh, you know we will see that 12 records from today will be present in the form of a Parquet file. So if we go to S3, this is the bucket. So yeah, month is May, day is 25. So this is the file that we've received from Lambda, which has exported today's details to S3. So now we have we have the Athena, we have the database inside the Athena, and we can perform queries directly from the Athena console. So if I yeah, we can use simple SQL to perform queries. So if I just write a sample query. So this is the name of the table, click events, and I'm just writing select star. And if I click on run, yeah, so we can see that this query select star from click events has returned the entire data where it is grouped in the city, page URL, device type, and all the attributes that were captured during the time of the click. So this is the highly optimized version to perform data analysis, since the file that we're trying to analyze is in a standard format which is specifically designed to analyze data. And now we have the database inside Athena where we can directly perform SQL queries. So even though the data that we're capturing is not in standard SQL format, we are using Parquet and AWS Glue to convert it into a standard format where the Glue crawler will detect the schema so that it is compatible with SQL, and I am able to perform SQL queries over here. So now the last step from the architecture diagram is to visualize the data. So we're seeing all the data here, but there's a lack of visual representation as to what is the most used city or most clicked button or most used device. So the service that we're using for data visualization will be Quiksight. So Quiksight is a service in AWS that is used to easily perform data analysis and create interactive dashboards. So that's what we're trying to create now. We have the database from Athena and we have all the data. So all I have to do is click on new analysis, and if I just try to create a new data set. So if we remember, we were using Athena as the data source. Like the Athena was using S3 as a data source internally, but to visualize the data, we will be using Athena. So if I click on Athena, it will ask me to provide a name. I'll just provide a random name, and I have to choose the work group. So if I choose the work group, just a second. Yeah, we can see that the work group for the click events is visible here. And if I try to validate the connection, it is validated. So the last step is to create the data source. Yeah. So now the Quiksight will ask for the database. So Athena has the data source and the database. So I have to just choose the database from Athena, and this is the database. ClickEvents DB is the database that I want to visualize. So yeah, the database has exactly one table, so it's going to appear here, and I have to just choose it and select. Okay, so import to Spice will be highly expensive for a small project. So I'll be using directly query your data. So if I just click on visualize, Quiksight will, analyze all the data from the Athena database, and I can use the visual types over here to visualize the data. So these are the fields that are automatically detected by Quiksight. It will look for the attributes inside the Athena database, and it will display everything over here. So if I just if I want to pie chart, I can just choose, I can choose any button that I want. So if I just choose button, and one more, if we have to group the button name by the by, let's say, month, we will see the pie chart. So this pie chart will tell us that we can we can easily visualize the data, and there are a lot of other options. So if I want a bar graph or any other piece of visualize type, so if I choose autograph, Quiksight will automatically ask for a few attributes, and will automatically do the visualization. So if we look at this graph, we'll see that count of records by button and by month. So for YouTube, the month is February, and there are 5 counts. So in the month, this will say that in the month of February, YouTube was clicked 5 times. Similarly, for Netflix, in month of February, it was clicked 6 times, and so on. So this is the power of Quiksight and Athena, where we can easily visualize any piece of data just by just by making a few small configurations. So now coming to the backend, like how are clicks getting logged actually? So, as I told you earlier, the backend is running inside ECS Fargate as a serverless container. ECS stands for Elastic Container Service, where it lets you run containers. And there are two options. One is Fargate, which is serverless, which means that you don't have to, manage the instance or anything. All you have to do is select the container and the configuration that you want to run. Yeah, so I'll be using Fargate, and I'll be using the application load balancer to distribute the traffic. So if I have multiple ECS containers running, for example, if the if the traffic is too high, if 50 people want to click use this application, then I can use an application load balancer, where I can inside ECS I can specify the desired number of instances. So let's say 50 people want to use this. So for example, 20 instances of ECS Fargate will be required, and all the 20 instances will be registered to the application load balancer. So from the front end, when a user clicks any button, the request will go to the ALB first, and the ALB, depending on the algorithm, for example round robin, it will distribute the traffic to the available ECS instances. So looking at the backend now, first let me show you the code for the to run the container. So this is the code base, which is which is available at my GitHub repository. Uh, I'll share the link to this repository after the end of this webinar. So if we visit the Docker file, yeah, so the Docker image will be using the Node 18 Alpine image, which will result in very small images. And yeah, so this is the backend. This is the main backend, server.js. So if we open up server.js, yeah, so we can see that this server, the backend, will be using DynamoDB, and this is the API endpoint. where all the clicks will be logged. So we can see that it is trying to capture these attributes which we saw in the data visualization part. So these are the attributes which the backend server will try to store it inside DynamoDB. So we're initializing the DynamoDB configuration over here, and the backend will try to send all these data inside DynamoDB. So if we look at the front end, we can see that, yeah, so this is the logic to capture each attribute. So when, for example, to get the device agent, like if the user is using a laptop or a desktop, so this is the logic, and this is the main function that will log the clicks. So we can see that it is it is performing a lot of operations, and this is the endpoint where the backend or the application load balancer is present, and all the requests from the front end will go to this URL. And this is a post request, and all these attributes will be sent to the ALB. The ALB will in turn forward this data to the ECS containers. So now if we go to the ECS configuration, the first step would be to build the Docker image of the backend. So I showed you the Docker file, and after building the Docker file, I will be storing it inside the ECR. ECR is the Elastic Container Registry, where we can store our Docker images. So this is the repository that I have for the for this backend, and this is the image, and you can see that the size is just 140 MB since I've used Node 18 Alpine. So there are other versions of images available. So if you just try to use Node 18, it can go up to 600 MB or even 1 GB at times. So when you're using Alpine, it will result in smaller images. So once we have uploaded our repository, uploaded our Docker image to ECR, the next step would be to create an ECS cluster. So as you can see, this is the cluster that I currently have. We'll try to create a new one. So yeah, if we just provide a name for the cluster, and we can choose the type. So as I mentioned earlier, the first one is AWS Fargate, which is serverless, which means that we as customers or we as users don't have to manage anything, and AWS will do it for us. But if you're using EC2, the configurations will be manual. While deploying, we have to configure the EC2 instances manually. So Fargate, while it is slightly expensive, it is serverless, and it is where AWS will manage everything. So we can leave the rest of the configurations as default. I just provided the name, and I chose the infrastructure type, which is AWS Fargate. So if I just click on create, this will go and create a cluster. So we can view the live progress in CloudFormation, but this will be over quite quickly. So yeah, so this is the cluster that I created just now, and it is provisioning. So we'll wait for it to get created. Yeah, so we can see that the cluster has been created. So we have to configure the cluster so that this cluster will run the backend. That is the Docker container that contains the server file. So we can see in the Docker file that firstly, all the dependencies are being copied to the container. Then the dependencies are being installed. Then the source code of the server is getting copied, and the port number. This is the important part. The port number is 5000, and it is being exposed by the container. This means that when the container is running, the port number 5000 will be exposed. So we can use port number 5000 to make connections or perform operations on that port. So this is the command that will be run by Docker. So this is basically just trying to run a simple JavaScript file, which is node server.js. So yeah, does anyone have any questions until now?
I think all good, believe. Nobody has any questions, right?
Yeah. So coming back, we just created a cluster inside ECS. We chose the infrastructure type as Fargate, which means serverless, and now we have to create a service. So before creating a service, there's something in in ECS called as task definitions. So we have to create the task definition first. So task definition is basically a blueprint for the application. For the application in my case is the backend container. So the task definition will be kind of the blueprint for the task. So if I just try to create a new task, so yeah, I'll just provide a name over here. This is the type. This is the launch type, which we chose for the cluster. We have to choose the same thing over here. And this is the option where we can choose the operating system type, the memory and CPU allotment for the containers, etc. So I'll be using Linux. So there are a lot of options available. So Linux will be the best choice. And for CPU, for this project, zero point 0.5 V CPU would be fine. So we have a lot of options available. We can either go with the 0.25 vCPU or zero point 0.5 vCPU. So yeah, we'll just go with 0.5 vCPU. And memory, we have a lot of options to choose from. I'll be choosing 3 GB and the role. So as you know, my backend server tries to uh, tries to insert a few data inside DynamoDB. So to insert data to interact with the DynamoDB, it will require some credentials. So instead of hard coding my AWS credentials in the backend file, since this file is exposed in the internet to as a security measure, uh, to prevent the exposure of my AWS credentials to the internet, we can create IAM roles to so that while this container is executing, that is when the backend will be running, the AWS will automatically pick up my credentials and the credentials from this role, and my put operations, the DynamoDB put operations will be successful without me providing explicit credentials. So this is the role. Yeah, we've chosen the task role, we've selected the task size, we've specified the CPU and the operating system and the infrastructure type. So the all that's left is the configuration of the container. So if we go back to the Docker file, we've read that the port number is 5000. So we have to map the port number 5000 in the container.
So just a little time check, Rohit. We have only 7 minutes left, and I hope
Yeah,
that
sure, sir.
yeah, no problem.
Yeah, we can wrap up with 10 minutes, sir.
Okay.
Yeah. So all we have to do is provide the port mapping, which is 5000, and the protocol will be TCP. So yeah. So this is everything that we want as of now. So yeah, we can leave everything as default, but coming to the health check, since we can specify the health check. So if we go back to the code, we can see that this app provides a health check API, which will return the server healthy message and a timestamp. So since I'm using the Node 18 Alpine image, the curl command, that is the command we're seeing here, the curl command is not available. So we can skip this step and we will be configuring the health check in the load balancer. So, so yeah, this is all the configuration that is needed. The port mapping, I have to choose the image from ECR. So if we go to ECR, Just a second. Yeah, so this is the repository and this is the image that I want to run. So the URI of this image should be copied. And I have to configure the container to run this image, to use this image. I'll just provide a random name. Yeah, this is all we have to do. And the next step will be to create the service. So the service is the most important part where we will be configuring the load balancer and the target group for the entire backend. So yeah, I just have to choose the task definition. The revision will be the latest one. Service name, it can be anything. Yeah, so desired tasks, we can set it to 1 or 2 or anything that we want. And the next step would be the load balancing. So if we just click on load balancing, then we have to choose application load balancer. And the container will be, it will be populated automatically. And we have to create a new balancer or choose an existing load balancer. Since I have an existing load balancer, we can use it or we can just create a new one. I'll just be describing the configuration that we will require since there's not a lot of time left. So yeah, so when we click on create a new load balancer, we have to create a listener, which means that the load balancer will be listening on port 443, which is for HTTPS 443, and I should be attaching an SSL certificate for the ALB. So I'll be attaching my SSL certificate, and the target group for the load balancer has to be created where the protocol will be HTTP, and we have to go to the target group console inside EC2 to edit the health check path to 5000 since the port number that is being exposed by the container is 5000. So yeah, we can also use service auto scaling, and this will require a few configurations. So yeah, so this is all that's needed to configure the load balancer and the target group. And what we can see is the visualization.